Hi friends, good morning to all of you. Welcome back to Ram's Academy. Today I am going to discuss an important topic called deep coupling of the circuits. First of all, I would like to explain like this. For information to the viewers, in electronics there are a lot of stages in a particular circuit. In a particular circuit, in the sense in a particular equipment, lot of circuits are there. Like if you take television, there are going to be audio circuit, there may be a video circuit, there may be a power circuit, like that. Oscillators, lot of things are there. These can be called as stages. Therefore, in this type of equipments, there may be only one power supply, and all the stages may be working in the same power supply voltage only. VCC, let it be 12 volt. When you have a 12 volt regulator, and then when you want to supply to 2-3 stages, what happens is the stages are going to draw the current from the same source simultaneously. Because of that, some problems are going to happen. That problem I would like to explain. When you join two circuits, you can call it as coupling. When you detach two circuits, then it is called decoupling. Like that, here we are going to use the word of decoupling in the circuits, and I will try to explain like this. As I said, there is going to be a SMPS power supply or a linear power supply, regulator power supply. There is going to be plus and minus 12 volt. There are going to be 3 or 4 stages. All are working under 12 volt only. When all these stages are working in 12 volt, with the application of 12 volt, and they can be connected parallelly. It's possible. When this is the case, this power supply is going to drive a current I. This is going to draw a current of I1, I2, I3. I1, I2, I3. Every stage is going to create certain function in the overall equipment. Therefore, this may be performing something, this may be performing something else, this may be amplifying the audio, and this may be providing a supply for horizontal oscillator in a TV, and this may be using this to develop a video amplification or something. When that is the case, the whole unit is functioning. What happens? Suddenly, they may be receiving 12 volt and suddenly this audio amplifier, a consumer is not going to use the same volume for continuous operation of the receiver. But in the beginning, he may be using minimum current of 0.1 ampere, and then when he raises, it may go up to 1 ampere. Like that, the current I2 is not going to be constant. It is going on changing according to the wish of the consumer. Like that, this is also according to the situation. This may be drawing a current according to the signal level. I1 may be varying, I3 may be also varying, because the variation in I2 should not affect the voltage which is applied to the first stage. Here what happens is, everything is going to draw different current. Because of that, I have already explained, every power supply has got an internal impedance. Internal impedance. When that is the case, when I1, I2, I3, they are all always throughout the operation, if it is constant, there may be IR drop here constant. When I2 is changing because of the volume, when the voltage is coming down here, that also will create a drop in voltage of 12 volt applied to another stage. Here also the voltage applied will be also changing. Therefore, the changes in the current of I2 due to the changes in the amplification of this stage will affect the performance of the first stage as well as the performance of the second stage. Therefore, though everything is having the same power supply from the same power source, the drawing of the current in one cycle should not affect the performance of the other cycles which are connected to the same supply. That is the intention always. Therefore, what we have to do, we have to decouple the circuits. Decouple the circuits. What do you mean by decoupling? Okay, fine. You may be using same power supply for different stages. Try to have a low resistance for every stage, low resistance in series with the positive terminal of the power supply and have a capacitor. Have a capacitor. This is the remedy for that. That is called decoupling. What do you mean by that? When you draw a current, when it draws a current, what happens is that may be creating a drop in this resistance, and also that may be adjusted because of the charging and discharging of this capacitor. But here, this voltage may be changing, but not this voltage. This voltage is not changing. Therefore, the effect of the changes in the current of the second stage cannot create any drop here. Here, the voltage is going to be exactly 12 only, but if the voltage has come down here, when it is coming down, that may be creating a charging discharging effect on this capacitor. Therefore, that variations is not carried away from this stage to the other stage because of this resistance and capacitor. Here, the changes occurring here are not creating a change in the current or voltage of the applied to the second stage or third stage. Like that, every stage is becoming independent in creating an effect because of the changes in the application of the voltage to the particular stage. This is called, technically it is called decoupling of one stage from other stage. So the effect is nothing. When you change the volume, it should not affect the picture in the TV. Though we are using the same power supply. That is what the aim of this decoupling stage. Decoupling stage is nothing but every stage in the power supply is going to have a resistor, a small value resistor and a capacitor, and the drop across that will be compensated by the charging effect of the capacitor. Therefore, these resistor and capacitor, these are all called as decoupling circuits. This is the decoupling circuits for this stage. This is decoupling circuit for this stage. This is decoupling circuit for this stage, like that. When you are simultaneously taking a power supply to 2-3 stages, always try to have a low resistance and a capacitor. Try to have low resistance and a capacitor. Try to have low resistance and a capacitor. The capacitance and resistance will form a RC network that will avoid such effects. The benefit of this resistor and capacitor is nothing but action in one stage will not affect the performance of the other stage. I would like to conclude this circuit. This is a very, very important thing for electronic engineers. Thank you.